Believe it or not, this oft-considered unhealthy, cholesterol-laden, stain waiting to happen fat is also the original ingredient in soap. But of course, it's not all that simple. It all can be traced back to the days of the caveman. An open fire, fatty acids dripping off a carcass and landing on the ashes, then a rain shower. And there you have it, the original soap.
The chemical makeup of soap originally has been based on a neutralization factor. First of all, fatty acids as we know them, they are considered in the pH scale of having pH values lower than 7. And when reacted with caustic compounds, such as sodium hydroxide, potassium hydroxide, the fatty acid will neutralize and form a byproduct, as we know, and this process is called saponification, and it develops into soap.
Today, much more goes into making a soap, including, thankfully, fragrances to make it smell appealing. And soaps and detergents have become part of our daily lives. Imagine having to wash your hands or wash dishes without soap. Or imagine not having detergents to run the dishwasher or do the laundry. But exactly how do soaps and detergents work? Soaps today are made up of surface-acting agents, or surfactants. They are responsible for the first key step in the cleaning process. That is, to make the water wetter.
Basically, water has an infinity for itself. It wants to draw back within itself. So if you put water on a surface, it does not want to spread out and make contact with the entire surface of the product you're trying to clean. These surface acting agents, or surfactants as they're called today, allow the water to become wetter, is the term that's being used. This allows the surface tension of the beaded water to break down and spread out onto the surface, allowing other ingredients within the formula to get down to the dirt and the grime on the surface and lift them off the surface for better cleaning.
There are two simple experiments that demonstrate how surfactants break down water tension. The first starts by sprinkling some pepper on top of some water.
As we notice, the pepper is harmoniously all around on the plate. But now we take a surfactant and put just one drop right in the middle. Lo and behold, the surface tension is lowered in the middle of the glass dish and causes a reaction that prompts the pepper to soul search and look for its own surface tension to be able to be supported, and will run to the edges of the container.
The second experiment involves getting a pin to float on top of water. In order to do this, use a tissue as support for the pin.
The tissue will wet out and drop to the bottom, but the pin, voila, will stay right on top and not fall down, which shows you the surface tension of that water is there to support the pin. This may be small and minor, but this is the big factor that boats or general cruise ships, what have you, all are based on this one little principle of being supported up on top via surface tension. We'll take a liquid detergent, take an eye drop, just one little drop, just put it right on top, not too far away from the needle, and if you'll notice, the surface tension goes down and the needle will immediately sink. The water itself by itself is roughly around 76 dynes per centimeter, which is the force action of support. As soon as you introduce a wetting agent or a surfactant, that surfactant will drop that tension down, maybe down to maybe 25 dynes per centimeter. That in itself will cause the water to become wetter and literally make the metal pin drop, because it does not have the surface tension to rely on to be supported on top.
Step 2 in the cleaning process involves the micelle structure of the soap. Micelles are electronically charged particles or molecules which have both hydrophilic or water-loving and hydrophobic or water-hating properties.
The second step in the process is for the hydrophilic portion of the molecule to attach itself to the water and the hydrophobic portion of the molecule to attach itself to the particles or the oils of the soils.
The soap micelle has this tendency to lock in due to its charge. The ability to have the hydrophobic portion lock in with what is hydrophobic that's on the fabric, but the dirt particle. They will be attracted to each other, while the hydrophilic portion will be out in solution, which with mechanical agitation will allow the removal of the dirt particle be completed.
In step 1, you saw how surfactants cause the surface tension of water to drop, thus allowing the soap to penetrate the soiled particles. In step 2, the hydrophobic portion of the molecule attached itself to the dirt particles. In step 3, cleaning agents will break down the particles into smaller portions. These smaller particles, once broken down, are easily removed from the dirty surface. This action is enhanced by using some form of agitation, such as rubbing your hands together, or using a sponge, or using mechanical agitation, such as a washing machine.
The fourth step and final step of the cleaning process is that these individual molecules then are held in suspension by the surface acting agents, allowing them to be rinsed away and not redeposited onto the surface.
Once the dirt particle is removed and suspended in solution, there are various compounds like phosphates that are used. They're known as builders in the formula, which prevent the reapplication of the material onto the fabric.
The 4 steps in the cleaning process serve as the basis for all soap and detergent manufacturers in formulating their products. They will then add any number of ingredients or additives depending on how the soap or detergent will be used. Special enzymes can be added if the detergent is targeting protein-based stains. Bleaches and brighteners are often added to clothing detergents. Moisturizers, conditioners, and fragrances often are used for soaps that will clean skin or hair. There are even chemicals which convert normally invisible ultraviolet light into visible light, allowing additional light to reflect off a fabric, making it seem more vivid. And if you shop around, you'll even find a soap that will take out that stain created by that spattering fat, which is what started this whole soap business to begin with.